so they can hear you. Okay. Ladies and gentlemen, this is Allycat's second Science Minute, and it is going to be discussed, or we're going to be discussing HIV tonight, because Tater Tom said so. So without further ado, here's Allycat.
Wait, they can't hear me.
Not well enough? Okay, hang on.
Yeah, see?
Alright, go ahead.
Okay, so, talking about HIV tonight, my favorite thing ever. Okay, that's not really bad. But, okay, so HIV is obviously a virus, and I wanted to talk about mainly, like the problems that we're having with HIV, not me particularly, but, scientists that are researching HIV. Um, So HIV is an RNA virus. It doesn't use DNA like we use. And so the horrible thing about HIV is that whenever it enters your cells, it uses your cells, your T cells or your macrophages, replication machinery, and it actually okay, so the central dogma of biology is DNA, RNA, protein. That's how it works. Well, HIV goes RNA to DNA to RNA to protein. So, so it actually uses RNA and changes it using a protein called reverse transcriptase and switches it to DNA. And the reason why we can't get rid of this virus, even with all the drugs that we have, is because it inserts its genome into your genome. So it makes its DNA, and then it has another enzyme that inserts its genome into yours. So even if the first virus in the cell is killed, it doesn't matter because your cell continually keeps making virus until it dies. And so all the drugs that we have for it are they are nucleotide analogs. So the four nucleotides of DNA, or I guess of RNA, are adenine, cytosine, guanine, and uracil. And so we make these bases that don't have a 3' hydroxyl group. So technically polymerase, not reverse transcriptase, polymerase is supposed to be able to, it's not, if you don't have the 3' hydroxyl group, you can't keep adding nucleotides to replicate these things. So we took off the 3' hydroxyl group, so reverse transcriptase wouldn't be able to make more RNA or make more DNA or anything, so it would stop it from working. But because it's an RNA virus, it evolves way too quickly, and so we're having to make all these drugs because it's able to use them anyway now. So I think AZT was one of the first drugs. Have you ever seen Dallas Buyers Club? That movie, it's about AZT. But it was made, I think, in like the late 80s, and we can't use it anymore. I mean, it's practically useless because that was actually made for thymine. It was a base analog for thymine, and we can't use it because reverse transcriptase has already, out-evolved it, and it doesn't work. So, but yeah, I don't know. Like, I just wanted to convey that a lot of people seem to think that, HIV isn't a problem anymore and that it's okay to get because, we have all these drugs and it's not a death sentence anymore, which is great, but it just evolved so fast that we don't really know how long these drugs are going to keep working. And it doesn't make you feel that good either because, I mean, all of your cells use these nucleotides, so it kills a lot of your cells. It's not just killing HIV, it's killing a lot of your cells. So you don't really feel good either, and it's just, I don't know, just the incidences of HIV are just really increasing because of this belief, and it's not good. And then, I don't know, I guess whenever you get AIDS, what's defined as AIDS, if you have a T cell count less than 200, that's That's pretty advanced stage. Whenever you knock out one portion of the immune system, you knock out pretty much the whole thing. So it's really bad. Yeah, and then there's also, I think Pepe wanted me to talk about this. There's some people that are partially immune to HIV because they are lacking receptors that HIV needs to enter the cells. And they actually have evolved this, they've actually evolved to lose this receptor in response to bubonic plague, not HIV. It just so happens to help prevent HIV from entering cells. But they actually evolved this to, be immune to bubonic plague. So, yeah, but I mean, I think that's all I got. Unless there's any questions, I don't really know.
Say, that was good. That was good, Allie. Everyone, give her a round of applause. Okay? If you have any questions for her, she will be glad to answer them in the chat. Allie, congratulations. Your second science minute is complete.
Thank
Her
you.
third will be on gravitational waves. We're not sure what time that will be, guys. But, yeah, everyone give her a round of applause. All right, she was great. She was really good tonight, guys. So, yeah. Say goodbye. There it is. All right.